I'm torn about recording this because there's nothing new in this. I've said everything that's in here before, but I'm not sure if I've said it all together this way. So let's see what happens. Okay, so the other day I started pointing out some of my things to a group of math people. They're probably mostly grad students by the look of it. It's a social media group, so it's kind of in that area, like those sorts of people, or people interested in grad level mathematics, master's, PhD, something like that, in that ballpark. So maybe some professors, maybe some, like me, people who don't actually have that level of official recognition of skills, but in some capacities are aware of that level. Anyway, so one thing that came up today, and I'm actually avoiding profanity, like I'm with these people, so I'm trying to play nice by the rules of all of the pussies out there. I'm trying to play nice by their rules. I'm trying to, you know, right? I'm not trying to piss anyone off and cause problems, okay? I'm just, with this, the way that I'm treating it, just matter of factly state what I'm seeing. And if you have a valid counter argument, beautiful. That helps. So far, really only anybody has been able to do is restate the things that I am reacting against, or question who I am with like ad hominem sorts of arguments. And I find that interesting because that tells me that I'm on the right track. Because you don't have anybody here who's actually able to make sound arguments against what I'm saying. I wish they could, honestly. Honestly, I do. So one thing that I said was it was about 1 plus 1 equal 2, right? Right? Right. Okay. Anyway, at some point I mentioned that um, Bertrand Russell, and I might be wrong about this because I did this from memory, so I could be incorrect about some of the details, but nobody called me on the details of it. So, insofar as that goes, okay, but I'll tell you what I said. What I said at some point was Bertrand Russell introduced type theory in order to patch some of these problems with set theory trying to do mathematics, right? Because recall, um, Russell was part of this movement of logicism that was attempting to ground mathematics in formal logic, and that involved incorporating like Frege and Peano's set theoretic ideas and formal logic ideas. And then this introduces problems because you get paradoxes with sets unless you introduce type theory. So Bertrand Russell introduced type theory, but it's really only a patch. And that was the thing I was pointing out, that type theory is only a patch to the problem, not an actual solution, right? So, for instance, if you have all of these different categories of numbers, right? So say you've got natural numbers, right? So you've got naturals, you've got, I'll just consider wholes to be the same as naturals for right now because the difference is fuck all. Integers, right? And then you've got like all of the rationals. And then you've got what, irrationals. And then you've got what is it? What, I guess reals is above that. Right. So, and this is a containment hierarchy actually. So reals contains irrationals. Well, it's partially a containment hierarchy. So naturals are a subset of integers, and integers are a subset of rationals, and rationals are a subset of reals. And irrationals is like a sister group to rationals, and then within rationals you get things like constructible numbers or the surds, and you get transcendental numbers, and all kinds of fun stuff, right? Okay, cool. Okay, whatever. So this is where set theory appears to shine. It appears to be doing some work for us here. Okay, one of the things that I said is that by introducing type theory, what you're doing is, by developing it this way, you're taking what are initially numbers, and by assigning them a type, you're giving them a unit. So it is no longer a number. It is now a vector. And importantly, these are not completely interchangeable concepts, even though we almost use the terms interchangeably, casually, in modern mathematics, and we should not do this, right? We have, for instance, complex numbers, but we will also call these complex vectors. We shouldn't do this, okay? Because we have this, like, what a number is something like 7, okay? The natural number 7, I'm okay with that. I'm not a big fan of saying it that way, but saying that, like, the naturals is the category of numbers, that's the fundamental category of numbers, I'm kind of okay with. I don't have any real strong arguments against that, so I'll go along with that. It's kind of like when people, so, like, I'm an atheist, but when people say, like, oh, like, the laws of nature are God, I'm like, okay, I can accept where we're going with that. I wouldn't say it that way myself, but I see where you're doing, and sure, I'll go with that. So that's kind of what's happening here. Like, I'll sort of accept that by naturals, what you haven't actually typed them yet. There is no typing that's been applied to the numbers. When you say naturals, you really just mean the numbers. Like, okay, I'm fine with that, and I think it can go the other way. I think somebody who really believes that Zermelo-Fraenkel set theory is valid can take what I'm saying there and be like, oh yeah, I kind of see why you might go that way. Like, I can accept that. And then we're going to start parting ways. Right? This is where we're going to start parting ways. Right? So for the naturals, you'll get things like, I might as well just put them up here right next to it, right? So for the naturals, you get things like 7. For the integers, maybe I should be a little smarter in my notation here. Here we go. For the integers, you'll get things like -7 and +7. Note that they have the same number component, and they now have a direction, right? That makes them vectors. There's a number component and a direction component. Integers are now vectors, and it's introduced via typing, via an application of type theory, per Russell. That's what got us here. When we add types so that we can clean up some of the paradoxes that we get with set theory, you end up changing the numbers into vectors. Okay. In rationals, you might get something like 7/8, right? You still have a 7 in there. The number of things you have is still 7, but now it not only has a direction, but it also has a kind of thing, right? So this would be +7/8, and you might have like -7/8, or 7/16, right? +7/16, stuff like that, right? And then irrationals, you might have something like 7π, right? 7√2. I'll just notate it like that so that it's right. Yeah, and then that's the category of reals. So then imaginaries. Okay, let's even go a little bit further here, and I'm just going to ignore reals because that's sort of just encompasses everything there. Imaginaries. Well, you can have +7i and -7i. So you see what's happening here? The let's see. Do I know how to write? Do I know how to type? Let's make these slightly more interesting. So that's -7√2. Sure, why not? This doesn't have a sign to it. It's not a vector. It's just a number. Okay. This has sign. Now, there's a consequence to this. So by the time we get to integers, This is what we can do addition and subtraction with. Okay? And the reason that we can do that is because of the sign. Because what addition and subtraction is, it's just listing vectors. If your things aren't vectors, like the natural numbers, you can't do that. You can't actually add natural numbers to each other, because once you try to do that, you've introduced vectors. Okay, right? So, 5 minus 3 equals 2, but at the same time, negative 3 plus 5 equals 2. Well, there's a hidden positive sign here, and there's a hidden positive sign here, and there's a hidden positive sign here. So really all you did was you rearranged these vectors here, this positive 5 and this negative 3. There is no addition operator. So this is another problem, right? The notion of operators was also introduced around this time, or at least became much, like the belief in them became much more amplified in this time via Frege and Peano and Whitehead and all of these guys. The people working within the framework of logicism, attempting to push the agenda that you can formalize math and you can ground it in formal logic. They have this specific agenda, okay? This is not controversial. They absolutely did. We know this. It's documented. They admitted it. They don't have a problem admitting it because it's what they thought was the right thing to do. And modern interpretations of mathematics continue to pretty much uphold this, that this was a good thing to do, and we've actually done it. That's where it becomes a problem, because we haven't. Right. So there is no... I always forget it does that. There is no actual addition operator. There is no subtraction operator. What we write and intend to mean to be those operators is actually the sign of the vector that we're adding or subtracting, or whatever the fuck, right? Listing. So the positive on the positive 7 in that example of the integer up here is what we would say is the addition operator, but it isn't. It's an integral part of this vector. It's the sign of the vector. It's the direction of the vector, right? And you can actually see this if we just say we pretend. Let's just do a make-believe where we're working only with natural numbers and an addition operator. Let's just play make-believe here and see how this looks, right? So we're going to suspend. I'm going to suspend disbelief. I'm probably going to be doing what you think happens because it's what you've been taught is what happens. And we'll see where this takes us, right? So say we've got, I don't know, so let's just have some natural numbers. 5 plus 6. So I'm separating everything off. Note up here, the way I'm notating it, I'm indicating that the positive and the 5 are part of the same thing. There's no space between there, right? I'm using white space to sort of indicate the words here. So here I'm pretending that this is not tied to this. These are separate from each other, okay? And I know this is how people are trained, right? Let's do, I don't know, 2, 3. We're probably in a good place at this point. Okay. And then we're going to say that gives us, what does that give us? That's 17, I think. If I'm wrong, I'm wrong. I don't really give a shit. I'm pretty sure that's 17, right? 12, 5, sure. Okay, anyway, so allegedly, let's just claim these are all natural numbers and we've added them together. Okay, problem is, what we have done is by adding them together, we have moved away from our reference frame, our origin. Our origin is 0, right? This is what establishes our reference frame. We have moved from the center of our reference frame, 0, some distance. So we're going in a direction, some distance. That's a vector. Automatically, these aren't numbers. They're vectors. So really what happened, and it's unavoidably true, what we did was this. We listed these positive vectors, and we yielded a positive vector away from 0. You can't add natural numbers. If natural numbers are numbers, you cannot add them. And if you can add them, they become things like integers or rational, like the other reals. They're not numbers anymore. They're vectors. This is a very basic, it should be obvious, I think, conclusion, but it is not what anyone thinks, because this sort of goes against some of the basic ideas that were central to logicism. Personally, I think that it goes against some of the ideas that were central to logicism, which made it invalid and eventually gave us the incompleteness theorems. But I could be wrong about that. But, like, clearly there's a problem here, right? If you want to call integers numbers, and you want to call 7, just 7, unsigned 7, dimensionless unsigned 7, just that, if you want to call that a number, but also positive 7, positive 7i, positive 7 square roots of 2, negative 17, negative 700, right? Anything where we can put a 7 in there, pretty much. 7 thirds, positive 7 thirds, negative 7 thirds, 7 thirds I, 7 thirds square roots of 2, right? Anywhere where you can do that, that's not a number, that's a vector. Right? These are all vectors. All of these. Problem is set theory. Set theory is broken here, right? So reals is supposed to include the naturals and the integers, the rationals, the irrationals. This is supposed to be a coherent set of things. But once we jump from here to here, we have changed fundamentally what we're talking about. We have gone from talking about numbers to talking about vectors. And I think this is kind of one of the sources of the problem, because what you want to do is you want to say, okay, the reals refers to all of this shit, and it's a containment hierarchy. But that doesn't work. The naturals should be outside of all of this. Should be a completely separate system from all of this. But under conventional set theory, it's not. And it's amazing to me that it isn't, because when you look at this, it's obviously true that you cannot add numbers. You can only add vectors. So your base operation that you're claiming exists, addition, induces the existence of vectors. And that's also the reason that we get integers in the first place, right? The whole point of integers is to incorporate the things that you get once you introduce the inverse to addition. If addition wasn't taking us away from 0, its inverse wouldn't take us into the negatives past 0. Right? You see where this is going? So in order to do addition, you're automatically not dealing with numbers anymore. You're dealing exclusively with vectors. So trying to say that 1 plus 1 is 2, and that what this means is that we're talking about the number 1 added to the number 1, and we're getting out the number 2, that is nonsense. That doesn't make sense, because you cannot add numbers. They have to be vectors. And once you have vectors, you really should be notating what your units are. If you're not notating your units, and you're trying to just strip it down to a number theoretical approach, you're doing it wrong. You've broken it. It doesn't make sense. It just doesn't make sense, right? And it's interesting to me, because at the same time that people will casually just violate all of this principle, they'll double down on the primary branches of functions, right? And be like, well, the logarithms with negative bases, those aren't really functions because they're the only way you can actually analyze them. You get multi-valued functions, and then you have to be really careful about it because the function is only defined over the angles 0 to 2 pi and all this stuff. And I appreciate what they're saying there, but that obsession, that also breaks things. And it's interesting that it's not matched with an obsession over being pedantic here. Yeah, so I don't think there's anything that I've said here that I haven't said before, but maybe the way I'm saying it and saying it all together is unique. I don't know. I don't know. Nobody watches my videos anyway, so who gives a shit?